Good evening. I'm Kurt Andersen. It's my great pleasure to be your moderator tonight. If you don't know, Studio 360, thanks to the Alfred P. Sloan Foundation, regularly covers exactly this kind of thing, the intersections between science and art. So it is why I was so eager to do this evening. The panel is an amazing group of people. Ken Nakayama is the Edgar Pierce Professor of Psychology at the Vision Sciences Laboratory at Harvard. He, among other things, has contributed to a basic understanding of eye movements, of visual attention, of the perception of visual surfaces and visual learning, and for tonight's program, most interestingly, in the perception and memory of faces. Margaret Livingstone is a professor of neurobiology at Harvard Medical School, as well as the author of Vision and Art, the biology of seeing. Her work is in visual processing, how we see color and motion and depth, how we perceive objects as distinct from their backgrounds, and how different parts of the brain actually process different kinds of visual information in parallel. Christopher Tyler is a researcher at the Smith Kettlewell Brain Imaging Center in San Francisco. His work, like the other two scientists here, involves visual perception, how the eyes and brain work together to produce vision, the visual perception of faces, how emotions and themselves can change facial expressions, even bleeding into features that don't actually physically change. And he will also talk tonight about the importance of 3D structure in the recognition of faces, how we recognize faces. Devorah Sperber is an artist. She has shown at the Brooklyn Museum here in New York, as well as at Mass MoCA, and has 5 solo exhibitions this year around the United States. Her installations, as you'll see, are extraordinary, involve spools of threads and pipe cleaners and map tacks to create these enormous and extraordinary artistic optical illusions. And finally, Chuck Close, who, as they say, needs no introduction. He is a painter, a photographer, a printmaker, now a tapestry maker, and among the greatest living American artists, who, of course, appropriately for tonight's panel, specializes in portraits, close-ups of faces. And by the way, he has a show that is open for another 10 days or so at the Pace Wildenstein Gallery in Chelsea. Please welcome our panel. I wanted to ask, first of all, if any of you have a moment, the classic aha moment, when you decided that this idea that we're all here to discuss, the human face and how we perceive it, really struck you with the force of revelation that this is something interesting. Christopher, I will randomly choose you to put you on the spot.
Not so much with faces. I had an aha moment when I was in high school. I wanted to do sculpture, 3-dimensional modeling, and I had this sense that in a block of stone there was something inside it, and I would chip away until I got to that living sort of object that was conceptualized in my mind but projected into the stone. This was a real aha experience that lived with me ever since.
The classic sense of the stone wanted to be X.
Right. No, but I understood that it was my mind projecting into the stone, and then it having a reality that I became the agent of releasing.
And you gave up your work as an artist to become a scientist.
That's right.
You just cut away the part that doesn't look like a head.
Exactly, exactly.
Did any of the others of you have a moment that was seminal, pivotal in that sense? In where you've ended up in terms of your work?
Well, for me, I've been a scientist and not really particularly interested in faces, but what happened was I was looking at the family photo albums many, many years ago with all the members of the family and say, Auntie so-and-so looks like so-and-so, somebody looks like so-and-so. Everything was fine. We were all having a wonderful conversation. And then my father chimed in and says, what are you people talking about? And I just realized that he just didn't really get the family resemblances at all. And I said, gee, that's interesting. So that got me quite interested in the whole topic of face processing.
Marge, I want to, and please, if you have a comparable moment, pitch it in. But I wanted to ask you about the scientific field's understanding of visual perception and how it's evolved in the last few years. Has, as my sense is, there been a kind of quantum leap in the last decade in the acuity of our understanding of visual perception?
Oh dear, no, I feel it's been very gradual, but clearly forward. And if I had to decide my aha moment, it would be trying to link science and art. Because for a long time I did the kind of research where I study how the human and the primate visual system in general is subdivided into separate streams that do different things. And I realized that op art beautifully illustrates the way op art works, illustrates the way that parts of our brain care about color and other parts don't. And so I would show op art in my scientific talks. And the only thing that people ever remembered about my talk was that I would show art. And so I started showing more and more art in my talks and realizing that artists do experiments just like scientists do. And that if a scientist is smart, they'll pay attention to what artists have figured out and try to incorporate what they're figuring out into what we're figuring out.
Well, I'm reminded, as I have been thinking about this panel, about the book that Jonah Lehrer published 2 years ago called Proust Was a Neuroscientist, making exactly that point, that in not only in visual art, but in literary art and, as well, and others, that essentially artists in their unscientific way are making breakthroughs, in some cases a half a century or a century before you scientists do. Has the ability to image the brain as well as we can these days been a huge boon to this work that you're doing?
Absolutely.
I want you to...
I think that was a quantum leap.
The imaging.
The functional MRI, functional magnetic resonance imaging. Suddenly you can see what every little part of the brain is doing in any task you can dream up. So you can really become a brain explorer in a way that was not at all possible before 1990.
And did that, when that began, did that transform what was previously thought, or did it simply confirm and refine what had been done up to that moment?
I think we're laughing because I think there's actually more of a refinement. I mean, you hope that there's been transformation, and maybe little bits of it, but there's been a lot of consolidation of what really was known from neurological studies for the last couple of centuries.
Marge, I want you to tell us what you love about the way the visual system operates, and why that is beyond what you said in terms of seeing the connections between art and science in this realm. What interests you about the nature of the work you do, of figuring out how this system of ours works?
Well, we see so effortlessly that it's hard to recognize what an impressive computational process seeing is. And if you think about it, the only thing up there is a bunch of neurons, and the neurons are either firing or not firing. And how do we extract information from our environment using light with just a bunch of neurons that either fire or don't fire? So people often think of their visual system as transmitting some kind of high resolution image up to the visual cortex that's represented, say, in some kind of electrical pattern across the cortex. But there's nobody up there to look at an image. So vision is all about extracting information, and how we extract information, how our brains do that, I think is just really interesting. And I think it's fun to look at art because artists also recognize that there's information. Sometimes the way they make discoveries and develop techniques takes advantage of the ways our brain extracts information. And you can see this in works of art. And I think, do I have to ask for my first?
You have some children's art I think you want to show.
Yeah. So if you, back one? Oh well. If you ask any child, 2 or 3-year-old child, to draw a person, you are going to get a head on legs, right? Everybody's done this. This tells us that the way in our brain we represent people isn't by a veridical photograph. There's bits, each group of cells is telling us something about who that person is, what they mean to us, what they look like, but it's not a veridical image. And you ask a child to draw a person, and what you see is what's important about recognizing that person. What's really important? The face. And if we go on a little further, as a child gets older, you get a body, but the body is not nearly as important as the face. And just a few weeks ago, if we look at the last one, 35,000 years ago, we assumed that females didn't look like that. But to some male in the tribe, there were important features that are distorted in a sense, but also that's what was important to the individual who made this little statue 35,000 years ago. So our brains are all about extracting information, and we don't register a lot of stuff that isn't important. And by looking at art, you can sometimes find out what's important.
They didn't think heads were very important.
Yeah. Right.
Veridical. What does
Yeah.
veridical mean?
Oh, true.
Uh-huh.
True to life.
True to reality.
So, and your point being that the brain in its ultimately almost unconscious way is out of these scattered bits and pieces is drawing an image, is putting together the bits that then somehow the mind turns into a recognizable image. No?
No mind, no unconscious. All that's up there is neurons, and all they do is fire or not. And everything you think and feel and see and perceive and think is you. It's just neurons firing or not firing.
So as we discussed in the green room, it is precisely, you're suggesting, like a computer, with each neuron being a binary 1 or 0.
But it evolved.
From or to?
Well, a lot of their design differences.
Uh-huh. And the fact that this extraordinary ability exists, speaking of evolution, obviously is exactly the sort of thing that the intelligent design folks like to think proves that there's a creator, an intelligent designer. Why should we not, beyond our faith in evolution, believe that that is so?
Wow. I'm a scientist, and so I believe the results of experiments and things that I can see and measure and feel, and I take the word of other scientists, and the overwhelming evidence is that we evolved.
Yes. No, I'm with you. But however, the thing you're describing is, which is to say, vision, is so marvelous that one understands how it leads people who aren't scientifically inclined to believe that.
Okay, but one of the reasons I love vision is that you can start with a single cell that responds to light, and you can have a pattern of cells that responds to light, and you can calculate stage after stage after stage how information is extracted to the point where we actually understand how we recognize faces. Mm-hmm. So you can really do it in a logical, sensible, wiring diagram kind of a way that doesn't require anything mystical.
No black box out there.
No
yes.
mystical. You don't need that.
Yeah. Chuck, you specialize and are best known for your enormous portraits of faces. Tell us, if you will, how you sort of play with the physiology of vision, and as you were creating this extraordinary style, to what degree you were sort of taking science into account as you did it?
I didn't have too much awareness of science because, as the lion's share of visual artists are usually learning disabled, I never took math or science. I never took algebra, geometry, physics, chemistry. I don't know the multiplication tables to this day. I can't add or subtract without using the spots on dominoes. So I was driven to do what I was doing, what I'm doing, by really the choice not to do something else. I was, and we may not know what we want to do, but we know what we don't want to do. And what I didn't want to do was just bloody my head against the wall, trying to prove to people that I was smart when I couldn't spit back the information that they wanted and give them the answers. So art saved my life. I drag in a 20-foot-long mural of the Lewis and Clark Trail to a history class that I was failing to show that I was at least interested in the material. But everything that my work is about is driven by my learning disabilities and my face blindness. We're gonna, it's how do you say it?
Prosopagnosia.
Prosopagnosia. You know this stuff? I knew at a very early age that I didn't recognize anybody. In the first grade, by the end of the year, I didn't know my classmates. I didn't know who they were, didn't recognize them, and I didn't know their names. So you have to be pretty charming. And you have to, Rauschenberg, who was severely learning disabled, said, we have to find other venues for our intelligence. We have to find another place to go put that stuff. And in my case, I realized that one of the things that I could do that my colleagues couldn't do as well as me is draw. So I used to sort of dazzle my classmates with my ability to draw something.
Even though you didn't know who they were, that you were dazzling.
That's right. and I gravitated towards the face because I was attempting to commit to memory the images of people who mattered to me that I swear to God, I did not recognize a woman that I lived with for a year, 2 years later. I didn't know, it's like I'd never seen her before. So by flattening out an image, in real life, if you turn your head a half an inch, to me it's a whole new head, somebody I've never seen before. But if I can flatten you out, I can commit you to, I scan it, I go back and forth as if it's a landscape, and I learn it like I map. When I move through the world, it's like I'm floating above the world, looking down on it, plotting my course. I made the face into a landscape. It's a Brobdingnagian world, like Gulliver's Travels, where the Lilliputians are crawling over the face of the giant. They know everything in the world about that face, yet they have no idea that they're on a face. And so it's that scanning and committing to memory of the essential facts of a person that allowed me to get to a point where these images were burned into my brain and I had a better chance of remembering them. In fact, I have almost photographic memory for anything that's flat. So you can see the appeal. Making sculpture didn't make any sense to me because you walk around sculpture the same way I walk around you. But flatness allows an entrance into it that is magical. Painting is the most profoundly magical medium that there is. There's space where there's no space. And it reminds you of life experiences. It's just colored dirt smeared on a flat surface. But once you understand that, you now have a way to deal in the kind of pictorial syntax that is equivalent of syntax in a novel or something else. The part-to-whole relationships, the marks, what they mean. And I put all my eggs in that basket because I wasn't good at anything else. It wasn't that I was greatly more talented than anyone else. I just cared more.
Just to be clear, once you paint somebody, say, you've painted Philip Glass famously. Does that make you any better able to recognize Philip Glass the next time you see him? Oh, yeah?
Well, most famously said, Philip said, I love this quote. He said, he is to me what haystacks were to Monet or bottles to Morandi. subject matter. Subject matter endlessly variable, alter all the variables, use fingerprints, use daubs of paint, use in any kind of medium and plug that imagery through it again, and you have a whole other experience. The content, in terms of an image, may stay the same, but as an experience, it's different each time you plug it through another set of issues. And then it does allow me to recognize it.
We have a video of you of showing you at work. For those few in the audience who perhaps aren't aware, let's take a look at that now.
Faces, powerful, friendly, clinical, frenzied. Faces by Chuck Close, some of Chuck Close. Artists have been making faces for as long as there's been art, but Chuck Close, one of the most important artists of our time, has given us a new way to look at faces. Move close to a Chuck Close and with every step watch the image deconstruct. A face made of dots and dashes, of circles of colors he calls donuts, of fingerprints. How he paints is incredible. That he paints at all is nothing short of miraculous. In 1988, a spinal artery collapsed, leaving him virtually paralyzed.
I used to work in a forklift truck, and I would go up and down. But since I've been in a wheelchair, it makes it a lot easier if I can stay on the ground and the paintings go up and down. My hands don't actually work at all. I have no use of my fingers. I have no grip. I paint with a brace that is strapped to my arm, and then brushes slip into them. People ask me how I can sit so close and know what I'm doing. And what I'm doing is sort of the visual equivalent of a musical chord. If you think about a musical chord, there are 3 or 4 or 5 notes being played by different instruments, and they all go together to make a sound. And from years of experience, when I put 3 or 4 or 5 colors together in a square, I know what they're going to read like from a distance. Could you hear at the beginning that I said it's like the equivalent of a musical chord? A composer can go in a room with no musical instruments and no musicians, and from years of experience know that if he or she gives this note to the bassoon and this note to the French horn and this to the clarinet, what that resultant sound will be with those musical instruments playing at the same time. It's not necessary and that seems reasonable, right? I do the same thing. I don't go back and look how I'm going, but I know from years of experience. I used to make full color paintings with made a red painting, put a blue painting on top of that, and a yellow painting on top of that. I learned a lot about mixing color and doing things, so that when it came time to putting colors next to each other, instead of on top of each other, I knew how these colors in proximity to each other would make the visual equivalent of a musical chord, and there's no reason for me to go back and look at it. I know exactly what it will read like.
I wonder, you scientists here, Ken, for instance, as you see Chuck's work and how he does what he does it bring to mind pieces of your work or the way that you have studied visual perception in some way that he's illustrating, or that he has found a way to some understanding of visual perception, being as he says, an utter non-scientist? Madam?
So yeah, I've done a lot of work on central and peripheral vision. Now I think do we have some, what is that what's next? Yes.
Yes.
So I think he's doing something that you can see the beginnings of in Leonardo da Vinci's work. So the Mona Lisa is a very famous painting, and I know you've seen it lots of times, but there is no, go back. Thank you. I know you've seen it thousands of times, but there's a reason why so many people love this painting, and it has to do with the fact that she looks really lifelike. She changes as you look at her. So if we now blow it up to the next one, what I want you to do is try looking at her eyes and think about what her mouth looks like. So you have to be aware of where your eyes are looking and think about something else. And then look at her mouth. And try going back and forth between her eyes and her mouth and see if she isn't smiling more when you're looking at her eyes. So the art historians say that what's special about the Mona Lisa is that her smile is ambiguous because it's blurry. But I think it's more than just your imagination or your state of mind, whether she's smiling or not. I think it has to do with with the resolution of your central versus your peripheral vision. So that's what's in the next slide. Your central vision is very high resolution. Can we go on to the next image? Yeah, so if you look at the center of that image, all of those letters are equally readable. So there is a dramatic difference in the resolution of your visual field between your central vision, which is very good at seeing little tiny things, and your peripheral vision, which is really good at seeing big things. So your central vision, that's why you have to move your eyes when you read, right? Because the letters are teeny. And so it turns out that I think that's what's going on with the Mona Lisa and with Chuck Close's paintings, is the difference in resolution between your central and your peripheral vision. So if you filter the Mona Lisa in the next image so that you can see what she would look like to your peripheral vision or what she would look like to your central vision, if you could see the whole thing with your central vision all at once, which of course you can't, you can see that she's smiling more to your peripheral vision than to your central vision. So as you move your eyes around the image, which you naturally do, your eyes are never still, her face, her expression changes, because when you've got your eyes away from her mouth, she's smiling. When your eyes are on her mouth, she stops. And so that gives this painting a dynamic quality. This is also true of photo mosaics. Like in the next image, you see Babe Ruth made out of baseball cards. With your peripheral vision, you see Babe Ruth. With your central vision, you see the little baseball cards. And so there's a dynamic quality to a static image. Chuck Close does this. With your peripheral vision, you see Philip Glass. With your central vision, you see the little circles. And so as you move your eyes around, the whole image changes. And so it makes this static image changeable, which is a very special thing.
That's called the Chuck Close program, you know. The guy at MIT who devised this system.
The photo mosaics, yeah.
That's what he calls it, so.
But what about
I came first.
What about what Mark says, Chuck? You aware of this peripheral versus central vision issue as you were kind of coming up with your image-making paradigm?
Well, I always built paintings out of incremental units. The early black and white paintings had units that were about 6 inches square, but the edges were fudged, so you didn't know it was made out of building blocks. At a certain point, I began to make paintings that had the incremental building blocks visible. The very first ones I did were just spraying. I wanted to make every square inch of the painting the same. No virtuoso art marks. So I sprayed a stupid little inarticulate dot in the middle of each one of these grids. I did this for a number of years, and I was getting ready for my first dot drawing exhibition. And it went from postage stamp images of 120 dots, the minimum number of dots to make a recognizable head of a particular person, to 140,000 dots for a 9-foot high image. So I'm on my way to the exhibition of my first dot drawing show, which was about 4 or 5 years' work. This would have been 1971, maybe. And on the way to my exhibition, hanging on a newsstand, is a Scientific American cover of the first computer-generated image. And I thought, oh shit, now no one will believe that I made these things without the aid of a computer.
It was your John Henry moment.
I had no idea that this was going on simultaneously. But what I did is very much like what the computer did. I was averaging together information, finding a mark that would stand for it, and clusters of those marks would build a situation that looked like hair or looked like skin, even though none of the dots themselves had any of those characteristics. So it's exactly the same system. I just prefigured it, that's all.
Do we think, Marge, do you think, and I know other people on the panel are using and have worked with Mona Lisa as a basis for their work, that Da Vinci intended, was using the dynamism of the eye and the peripheral versus central vision thing to create a kinetic sense in the work?
Well, Leonardo wrote a lot about his techniques. We have records of a lot of what he wrote, although certainly not all. He never wrote about this technique. As far as we know, he never did it again. We also know that he really liked this painting. He worked on it for several years. He carried it around with him for a while, and then he gave it to the King of France.
Who still has it, effectively.
Yeah. So the facts would lead you to believe that perhaps it happened, he recognized the dynamic quality, but he didn't know how he did it. That's my guess.
So, as Chuck is suggesting, he came to this extraordinarily sort of scientific discovery unscientifically. Maybe Leonardo did the same thing.
Well, artists discover things empirically. There is no question
Right.
about that. When they do it again and again, then you say they've understood the principle. He clearly understands the principle. I don't think Leonardo understood the principle because he didn't do it again.
Right.
What we do is so close to science in many ways because we impose severe self-imposed limitations in order to project ourselves into whatever we're doing, and that kicks open a door, and we go through that. If we don't like the way it looks, we back out that door, we alter the variables again and see what we can find. It's like a high school lab science experiment, and that's how you can progress using your own issues rather than wetting your finger, putting it in the air, and trying to figure out what the art world is doing. You back yourself into a corner. I think we are way too concerned with problem solving. The minute you're concerned about problem solving, you realize, well, this is the problem of the moment, and everybody's working on it. I think problem creation is much more interesting than problem solving. You ask yourself an interesting enough question, no one else's answers will fit. And if no one else's answers will fit, you'll have to come up with your own systems. And if you don't like the way it's going, you alter the variables again until you find something you want to do. I would assume that it's very similar to the way a scientist moves through ideas.
Absolutely.
But Leonardo is famous for developing the sfumato technique of this real subtle grading, which is what Marge is picking out in the filtered, the left-hand filtered image. So it seems he was playing with part of the idea,
Absolutely.
even though he may not have considered the juxtaposition so precisely.
We have another couple of images to show a different effect. Not that one, but
That's an attempt to look. I was in there early with the grunge look, but this I'd seen too many James Dean movies. This is how I construct one of my paintings now. Everything from the diagonal line down is the first pass. And I put colors down relatively capricious and arbitrarily. And then on top of those colors, in a series of 4 or 5 or 6 other colors, I plot the corrections necessary to move it from something that's wrong to something that's right. It's the equivalent of, if you work with a palette, that's equivalent of shooting an arrow directly at a bullseye. You hope that you made the right decision out of context, and then when you drop it into the painting, that you made the right decision. I prefer to do something which is much more like golf. Golf is the only sport, you can call it a sport, that moves from general to specific in an ideal number of course corrections as you're moving through the landscape. You may not even be able to see the hole from the tee. The first one is just out there, a leap of faith. The second stroke corrects that. The third stroke corrects that even more. And in 4 or 5 or 6 strokes, you placed yourself hopefully in the green, and you putt out, and you place that ball in a very specific 3.5-inch diameter hole that you found by moving through the landscape and making course corrections. And that's a very different way of working than mixing a color and putting it on, because it's all found in context, in relation to pieces that are already done, and in anticipation of things that will come later. And it's like writing or words, any incremental way of working. You just shove something up against something else.
So it is, as we're talking about the parallels between science and art, it is experimental in its, in its nature. Christopher, you have done fascinating studies about where you add noise, visual noise to portraits to try to figure out how we're perceiving those faces.
Well,
how did that work?
It's actually very, I didn't realize that Chuck started with random colors, but it's the same concept. So I'm starting with the Mona Lisa, if we can see the first image, and just putting completely random noise. Don't move them for a second. Completely random noise on the face. And what's interesting about this is it captures many of the activations that we see in people's faces in real life, so that the noise is then interpreted as changes of expression. And so what I've labeled on the bottom is what I think the expression looks like. And you see, these are just random noises, and yet Mona's changing her expression all the time.
So you put the random noise on, and then you find this one looks happy, this one looks...
this is just how it looks to me. And so then I did a scientific study of this. I got a group of people. If we can go to the next slide. I got a group of people to say whether the noise looked happy or sad on 100 different samples. And I selected the happy ones and the sad ones. And here you see them added to the Mona Lisa. So this is another art form that nobody's developed yet, but maybe Chuck can pick up on it. Just use added noise as a way of modulating something into something else.
I've used noise all along to soften
maybe
the grid.
So I'm discovering something you're using already. So now here I took the top half of the noise and just added that, and the bottom half is the precise original Mona Lisa. And you see that there's very little difference in her expression. So this tells me that what the people were selecting was not what's in the eyes. Now the next slide shows the bottom half of the noise that people selected added to the face. And yes, you know that the mouth is changing expression, but look at the eyes. When the happy noise is added to the mouth, the eyes are smiling. The happy noise, when the sad noise is added to the mouth, the same eyes look sad. So we're projecting parts of the expression from one part of the expression from one part of the face to the other part of the face. And I conclude from this that it's incorrect what we've all learned, that the eyes are the window on the soul. The mouth is the window on the soul in the sense of how we're feeling, and the eyes are just modulators on that, depending on whether it's happy or sad.
Maybe that's why I paint donuts and hot dogs. The mouth is... I'm thinking about eating the whole time.
Okay.
Now, what kind of experimental work are you doing or can be done or has been done to sort of get at that phenomenon in other ways than sort of messed up Mona Lisas? I mean, is there a way to describe neurobiologically what's going on there when we make such an extraordinary perceptual change from one image to another? Well, what exactly is going on there? It's simply the degree to which a mouth is smiling or not.
Right. Well, the point is, I had no idea, and I used the noise as an experimental tool to dig out what was the underlying principle. Then it's over to Marge to start probing in the monkey's brain and recording the cells and seeing how they're carrying it, how they're interacting in different parts of, let's say, the face area, to see what that configuration effect is how it's actually encoded in the brain.
But I should say that I think it indicates that we see the face as a whole, not just individual parts. Just by, in other words, just by changing the mouth, you see the whole face differently, and that'll come up a little later.
And Marge, when you do whatever you do to monkeys' brains, what do you discover about what Christopher is saying in this realm?
You told me I was supposed to talk about that later.
Oh. You know, we play it, we go on the fly, we play it by ear.
We could, but then what are we going to do with all the visuals that I have at the end that discuss that?
Okay, all right. Then, Marge,
We could
will wait till the
skip
end.
to the end if you
No,
want,
no,
but
no.
I think it's going to make Justin really angry.
I think that's true. Devorah, you are an artist who, unlike Chuck, I would say, has been inspired directly and specifically by the scientific work, rather than sort of finding it on your own, finding these effects on your own. How did that happen? How did you begin thinking, oh, I'm blown away by these scientific findings, or was there a eureka moment?
Well, first there's the creation of a work of art for me. And because I've seen it, the way I work is digitally, so I know everything exactly how it's going to turn out before I even begin making it. And when it finally appears, it's big deja vu, and I become the only person who can never experience my work. So then I have to look to other people, and I look at their experiences and try to assess what's happening for them. And that's what really led me first to Marge's research, understanding, people's, how people are perceiving work based, on the biology of vision. And then it informs my work, so then the next piece is more literally related to the scientific survey. So it's a back and forth, but I think we're all saying the same thing. It first starts off, you do something, and then you look at it and you think a new thought about what you did, and then you do something else, and then again you look and you think, oh, is this in the right direction? Is this more interesting, less interesting? Does this open up a new question that is going to lead to even more interesting explorations?
Let's take a look at the video about you and your work so the audience can see the extraordinary installations you make.
I create often very large-scale works using thousands of ordinary objects, such as spools of thread, chenille stems, also known as pipe cleaners, marker pen caps, Swarovski crystals, and other mass-produced objects.
Sperber is interested in the way artists use technology. Her work looks at the digital image and its smallest component, the pixel.
All of my current body of work is created by deconstructing an image into pixels and then translating the pixels into the palette of each particular material and then reconstructing it by hand into the original image.
She uses mass-produced objects to represent individual pixels. The thread spool is a favorite material for this technique. Today, Sperber is using thread spools to make a deconstructed image of Star Trek's Mr. Spock.
Basically, what you're seeing here is a thread spool assembly station, and there's a partially assembled map with each color corresponding to a map and also to the spool of thread. And how this whole process begins is I start with a JPEG, a digital image, and any JPEG is constructed from up to thousands and thousands of pixels. So what I do is I break that JPEG down into an exact number of pixels so that each pixel corresponds with one spool of thread. So in this case, this is 29 pixels wide, and that will be the number of columns on this piece. And I now have a custom software program that helps me translate pixels into whatever palette, in this case, spools of thread. And that is the final product. And this is kind of like a very enlarged JPEG in a sense, that you're actually focusing on the individual units of color versus the whole image.
The work is completed when Sperber sets up a viewing device.
But what happens in the viewing sphere is that it shrinks or condenses those pixels back into their photographic origin. So you can actually see how radically different the image looks when it's expanded and contracted, and it shows just how limited our human perception is, that you subtly shift scale and yet our interpretation of reality changes. In one case, looking at abstract spools of thread, abstract blocks of color, and whereas here you have, the focus being more on the recognizable image. But there's another aspect of the sphere that interests me, that it functions like the human eye in that it inverts imagery, like the retina. And it functions like the human brain in that it's taking this raw data that makes no sense at all and it's assembling it into something recognizable. This work is a life-size interpretation of the Mona Lisa. And if you look directly at the thread, you could see that there is very little information there. But what you're seeing in the viewing sphere is how little information your brain needs to recognize an image that it's already been exposed to. And one of the things that most people find particularly baffling about this piece is that you can actually make out her facial features in a very subtle way. In fact, this is all there is. There's no face at all. So it's actually a perfect demonstration in how our brain is actually projecting an image, that it doesn't exist out there in the world like we think of. Very few paintings can be transformed into such a small thread spool work and still function. The reason this functions is because we all know what the Mona Lisa looks like. So if you'd never seen the Mona Lisa, which I've never met a person who hasn't, who knows what they'd see, but they wouldn't be seeing the Mona Lisa.
The choice you've made of creating these beautiful spherical viewing devices is an interesting one. Did you think from the beginning that you would do that, or did you ever imagine that you would simply have the things?
No, I actually intended for my pieces to be viewed very similar to Chuck's work. He was a big inspiration in many different ways. I won't get into it because he's already heard it. But I was working in a very small studio on Bleecker and Mott, and it was about 100, maybe 150 square feet. So my first thread spool work was 6 feet high by 10 feet wide, and I could barely even see the whole thread spool work without backing out in the hall. And so I wasn't sure if the piece was working. And there happened to be some binoculars in the studio, so I just flipped them around just so I could see the piece from a distance. And I had such a big aha, what does this mean kind of moment, that it really made me think about, and my brain really felt like I had a jolt of surprise. And it really made me reconsider the whole notion of gradually creeping up and moving away from an image and questioning, what does that mean, that something can be so radically different? To me, it eventually kind of shook down into thinking of human perception as like being in this tiny band, that we're living in a tiny band of scale-based reality with all this stuff superimposed up to the macrocosms and down to the microcosms, but all we feel is real is all of us sitting here in this auditorium. And yet
it sounds very like what you've just said. Sounds like Brian Greene's description of string theory and our limited perceptions the other night.
Yes, I was just referring to that.
One of the things that's interesting about what you do is artists for years, generations, centuries have used a reducing lens to get greater distance on what they're looking at, and it inverts the image. And when you see it see the painting you're working on every goddamn day, upside down and smaller, it gives you a chance to see the forms and the shapes and everything in a fresh way, and problems pop out, and you immediately know what area is giving you trouble. So you've actually done the opposite. You've used it to zero in and focus and make something go from general to specific, when artists traditionally use something to go from specific to general. It's essentially the same tool.
And Devorah, some of your work was specifically in reaction to what you had read about what Marge's work has been.
Right. For instance, the piece here, that I did a series of Mona Lisas, 2 Mona Lisas and The Last Supper for the Ljubljana Print Biennale in 2005. And since it was a print biennale and I'm not a printmaker, what I did is I was invited by the Brooklyn Museum to do this, so I came up with this installation that was based on really what happens when things are mechanically reproduced, which experiences are lost. And one of the experiences that is definitely lost is scale. And we all know the Mona Lisa is smaller than we think, but actually when you go and see it, even if you know it's smaller than you think, you still think, oh my gosh, that's so much smaller than I thought it would be. So what I wanted to do is to reintroduce some of these lost experiential effects, lost through mechanical reproduction. So in this case, I've reproduced the Mona Lisa life size, and that determined the number of pixels, or the lack of pixels that I used, 17 across by 25 high. And if you go to the next slide, this is the one that, no, this is just an anamorphic distortion. That anamorphic perspective is attributed to Leonardo da Vinci, and I just thought it'd be an interesting piece to do. But go one more slide forward, and then we're gonna go back. This is the work that was directly influenced by Margaret's work, and I basically read through her entire book, Vision and Art, the Biology of Seeing, and I thought it was really interesting what she was talking about when the low spatial frequencies and how the smile can only really be best seen with peripheral vision. So what I thought was, well, the viewing device itself, these spheres, create a distortion. So it's kind of making the smile visible using central vision. And so really, I think as an artist, I'm not like trying to illustrate your studies, but I use it as an interesting, a starting point to do this work instead of the infinite numbers of other things I could do. And it also it's a type of justification that, for me, I'm probably insecure or something, but if somebody attacks what I've done, I can think in my mind, but you know what, there were some really interesting underlying issues here that, yeah, maybe they don't like the work, but boy, this was worth doing, so.
It was a wonderful show, too. It was really wonderful, the Brooklyn show.
Oh, thank you. So, and then, going back one slide, this is another interesting thing. I don't know if you can see what this image is, but it's of a hand with a digital camera popping up in front of the Mona Lisa. And I've shown that work here at the Museum of Arts and Design, and a lot of people are struggling with, is that the Mona Lisa's arm, blah, blah, blah. I'm thinking, how could that be her arm? That's ridiculous. But that piece is currently in Paris. Every single person there, because they have the direct experience of the Mona Lisa in their backyard, they all instantly see the joke of that when you see the Mona Lisa, you're actually, another experiential component often lost in mechanical reproductions is the fact that she's surrounded by crowds of people. And then the one other thing about this is most of her defining characteristics are missing, and yet you don't have to think twice. You just know it's the Mona Lisa. So again, it's showing just how little information we need to recognize something that's so ingrained in our brains.
Fascinating. Have you tried it with less recognizable, less iconic images?
I have, and then it's also a great demonstration of how much is actually projected down, and I'm sure that's not quite the scientific term, that I did Da Vinci, that beautiful drawing, that all brown, drawing a self-portrait, and because not everybody has it in close access, that some people kind of vaguely see different random people from history, and some people know the painting. So, or like I've done American Gothic, where some people recognize it, some people don't. You see them sitting side by side, and it's the difference in their capacity to project down a complete image. So it's even maybe more interesting if you're thinking about the brain in action to have a piece that's not recognized by everybody.
And what is the evolutionary basis for this? That to take as little data as possible to decide that that's a tiger in the bushes or whatever?
Absolutely.
Yeah?
Yeah. It's information processing. You need to extract what's important.
I can look at those all day long. Chuck, when you hear or read scientific descriptions of the effects that you're achieving in the way that you achieve them, is there a Hawthorne effect? Do you change the way you do things because you now are aware of what you're doing in some optical scientific way?
I don't know that I read that much that I would find applicable. I think more than anything, you want to change what you're doing in the studio each day. And if I simply change subject matter, I'll be doing the same activity every day. And that's what gets boring. So I think I'm more driven to find other processes, techniques, procedures, material, scale, to change what it feels like, what I'm actually doing in the studio. And that's pretty much self-driven, and it's pretty much a response to the feeling that you get when you've plowed that field so many times that you can do it in your sleep. But I think it's scientific to the extent that it's this construction of severe self-imposed limitations that won't guarantee you're going to make anything interesting, but it will guarantee you're not going to keep making what you were making. And I think that's how we move forward. When you don't want to do something one more time, you don't allow yourself to do it. The choice not to do something is almost always more important than the choice to do something.
Christopher, I want to talk to you about your theory of eye centering in art, in portraiture in particular, as a historical sort of given practically in portraiture. What do you mean? How is that central to portraiture in art?
Well, what's interesting about it is it wasn't a given. It seemed as though nobody had conceptualized that that was what's happening in portraits. So I started noticing that there would be one eye centered in a portrait. And this is despite every art school teaches, when you do portraits, make it interesting by making them asymmetric. So you're taught to focus on asymmetry. You can correct me on this if...
I didn't follow those rules.
Right, but they were taught, right?
Yes, sure.
Yeah. But nevertheless, it seemed as though one eye almost had to be on the center line, and that this was not expressed. I couldn't find anywhere in the history of art where this was explained or taught or promulgated. So here's an example with the ubiquitous Mona Lisa. Although you probably thought that she was sort of roughly centered on her nose, it turns out one eye is right on the center line, and this is true of other portraits. You see some more slides. So here's a self-portrait by Tintoretto. His head is shifted to one side, almost as though the eye needs to be on the center line. And so I did a survey of portraits over 600 years, as shown in this slide, starting with Roger van der Weyden and ending up with Picasso. And it's not every portrait by any means, but it's the vast majority, 75% or so, fit within this roughly 10%, plus or minus 5% of the center, one eye tends to fit. And let's see, the next slide shows this was a study that a school teacher did. She read of this theory, and so she asked her students to draw a head, a portrait or a face, on a piece of paper. And then she measured the results and sent me the Excel spreadsheet. And this is the result she got. You know, there's an eye centered right in the middle of the frame in almost every case.
Do you think there's a relationship to, I know we choose one eye to look at, and some people look at the right eye and some people look at the left eye. If you split people's image down the middle and you make two lefts or two rights, if you are right eye, if the right eye is a happy eye and the left eye is a sad eye, and you're looking at the right eye, you think that person is happy. The person who looks at the left eye and sees a sad eye thinks that person is sad. Do you think there's a relationship between that? I mean, are you doing with the portraits essentially the way we relate to each other in real life?
I think that's true. I did think originally it was the artist choosing this, but I think to a large extent It's how the sitter is choosing to sit. If you have a conversation with somebody, you often find that they're arranging themselves so that one eye is centered on their body frame. And that you touched on many deep issues about the asymmetry between the two parts of the brain and how this projects into asymmetry in the expression. And it relates to what Marge was saying about we have only one fovea and two eyes, so you've got to choose to look at one eye or the other, or maybe flick back and forth, but it's not a comfortable fit. And so all these issues are brought out by this sort of discovery in the history of art.
And do I take it that your belief is that it is indeed the sort of natural human sitter's choice that produces this effect over 600 years?
I think that there's a power spot. And you actually find this on TV. You can take your television and you can draw a circle where I'm saying the eye is, and you'll find that in every soap opera, whenever a character wants, not that I spend a lot of time looking at soap operas, whenever a character wants to make a big point, they'll bring that eye to that place on the screen, just at the moment that they're making that point. I've not done a scientific study of that, but that's my observation.
Yes. For you researchers out there,
yeah,
there's new work to be done.
Email me.
Yes, exactly. Devorah, as it happens, and truly as it happens, because I don't think this was part of the construction of this panel, some of your work is also inspired by Christopher's work.
Right, because while I was doing my research for the Ljubljana show, I stumbled upon an interesting scientific analysis of the Last Supper, which places the Christ figure's right eye at very near the center line, but also it's the single vanishing point for all architectural elements in the mural, and a single vanishing point for the entire site if you stand at a certain location, which is something not known about the painting because we all see it out of context. But to go back to Christopher, after I learned about his study, I remember going to museums and I thought, well, how did I never notice this? And how different it was to actually look at the eye-centered portraits and how it felt very comfortable. My eye had a really nice pattern around the painting versus when it was nose-centered, how I didn't know where to go. And so I felt very much like, when it was a centered eye, that I was having a relationship or a conversation versus this fluttering, not knowing where to go. So and it is interesting. Once you know it, go see a bunch of portraits and you'll think, how did I not notice that? So it was amazing you did. And this is a little bit related, but Da Vinci said something about to best appreciate three-dimensionality in paintings, you're better off closing one eye and viewing the work from a distance. And when I thought about that the viewing sphere really offers that perspective by focusing both eyes on a single point in the sphere and by shrinking the image as though it's being seen from a great distance, that perhaps is adding to the illusion of great detail when in fact the resolution is quite low if you think about the number of pixels/thread spools. So the next slide. So like the Mona Lisa that's surprisingly small, the Last Supper is surprisingly large. It's 29 feet wide. And I was surprised. I thought it was a poster. I thought bigger than a poster, but it really shocked me. So I thought, okay, I'm going to create this thing life-size. And if you go to the next, so this is the other aspect that's lost in mechanical reproductions, the amazing relationship of the mural to the site, that it feels like an extension of the space, and the architectural elements, going to the next slide, please, how they continue right into the mural, all to the Christ figures very close to his right eye. So that was my justification. I had all these layers of justification for doing the Last Supper and the Mona Lisa for that show based on the effects of mechanical reproductions, and thus tying it into a print biennale, which apparently my work was so controversial because it wasn't really printmaking in a way that they're still talking about it in Ljubljana. It's not a bad thing. So as I stumbled upon this survey, then it led me to Christopher's survey, research online, everything. I couldn't do this work. I would never have found any of this had it not been for the digital era that we live in. And one thing I think is really interesting is that we're always affected by the eras that we live in. You think two artists have the same thought, one copied the other. Well, not really. We're all being exposed to the same. Yeah, it's totally like you were doing the beginning of the grid at the same time that pixels were being developed, and yet you weren't inspired by the pixel. So Yeah, it is in the air. So going to the next slide, I ended up doing a series of work that I call my eye-centered portraits. And unlike that Mona Lisa where I'm using the distortion of the lens to create that real round face, in these I've actually negative spherized it, correcting this distortion. So if you go to the next slide, you'll see that the image looks very flat, but nobody questions this. It's kind of funny that no one has ever said, well, why isn't that image rounded? But again, I've really exaggerated the eye-centeredness by making, cropping the image to a circular format, and I'm hiding the fact that I've distorted it also by, the edges would be very curved in if you saw the distortion that I put in place. So this was an image from Van Eyck. The next one is Vermeer. And I selected works from a wide range of artists and eras to show, just how common this the eye-centeredness was. And incidentally, there's something weird about this particular Vermeer. Go to the next slide. It's not visible really in this image because I've negative distorted it, which is then corrected somewhat. But these Vermeer images look more lifelike if they're made 4% negative spherized. And you know what I mean? Like you're projecting something in a bowl that can be done in Photoshop with a click of the button. And we were talking earlier before we came on about the use of optical devices, and I thought it was interesting that these Vermeers tend to look a little bit more lifelike with a slight negative distortion of a sphere. So it really, for me, adds more credibility.
It's probably the lens distortion of the camera obscura.
Yeah.
That he used.
Yeah. Or didn't use.
So she's correcting. Yeah. We don't agree about these things, but.
We've got David Hockney backstage.
Bring him on.
Yeah, I think it's, I think that you have perhaps corrected. We know that Vermeer had a friend who was made telescopes and was a what do you look at the stars?
Astronomer.
Yeah. So in all of Delft, there probably was he only had access to one lens. You wouldn't have more than one. That would be unbelievable to have two lenses. So the same lens has probably been used for every one of his paintings. And what you've done is correct the distortions in that very primitive, early, poorly ground lens and given it something that was taken away in the original case. Mm-hmm. And I thought about you too when you're talking about noise. Artists have always squinted to see what they're looking at. And it is the physical equivalent of adding noise. It does away with detail, and it gives you general shapes. And you can see the nature of what it is you're doing so much more clearly if you squint your eye. And artists have always done that. And I think it is the same sort of principle.
Well, not only that, I don't know if you ever go into an art gallery and show any kind of interest in a painting, but if you do, they're on you like immediately they're trying to sell you the painting.
Not in Chelsea.
Not in Chelsea.
They stay behind the desk.
In San Francisco, this is how it works.
Complain about no sales.
And if you show interest and really act as though you might buy the painting, they'll take it and they'll take it into an inner sanctum, and they'll turn the lights down. And as the lights go down, you get two effects. One is you get the Purkinje shift of the colors, and the other is that you see the noise of your rod vision, which is very susceptible to noise. And so you'll see a real-life version of the kind of dynamic that I showed in this sequence. And they do this to bring the painting to life so that you'll pony up with the amount they want for it.
And everything we've looked at and everything we've talked about are not sculptural, but essentially flat images, flat paintings. Chuck talked about how he needs to turn the world flat in order to understand it. Some of your work is about how you believe we perceive faces in our brains in 3D.
Well, I was very interested to hear Chuck say that he only relates to things flat, and that is part of his prosopagnosia. I hadn't thought of prosopagnosia as as relating to the three-dimensional structure of the face, but my analysis, my data suggests that we really understand faces three-dimensionally, even though all studies that look at it scientifically treat it two-dimensionally. So that's what I'm showing here. And it's a thing that's become, keep this for a moment, the cartoon industry used to draw line cartoons. That's what a cartoon means, right? But in the last 10 years, everything's gone 3D. So you know how Shrek looks in 3D. Can I have the next slide? So now it's much more vivid, and you get a whole different appreciation of the face. And you can do this with the kind of filtering that Marge was talking about in the next slide. And you see it flattens down, and so you lose that three-dimensional structure of the face. So I think that I've talked about the two-dimensional features brought out by the noise, but there's this big three-dimensional aspect to face perception and object perception in general, which is a very important and poorly understood process of how we would encode that. Do I have another slide on this? Yeah. So this just illustrates this sort of filtering process. Here I started with a model picture and did the same kind of low-pass filtering that Marge was talking about. But I also introduced the idea of symmetrizing the high-pass filtered face. And so now you can see the figures on the right, that the top one looks very sculptural, three-dimensional, whereas the bottom one looks just two-dimensional. Is there another slide? Yeah. So these are shown in full. You see a real contrast between the two aspects of face perception, the mask and the features. Do you think of that?
And what does this tell us about how we see faces?
There's more than one way to skin a cat.
Yes.
It relates a lot to the literature in computer science and in perception, where everyone starts with a two-dimensional face drawing and shows photographs, and everything's 2D, and all the analysis is how close the features are together, and there's no awareness of the three-dimensional structure. And I have a whole program to explore how important three dimensions are in things like face perception, how it's another avenue into how we see faces and objects.
Ken Nakayama, you are an expert in what apparently the disorder that Chuck has, prosopagnosia. And before I want to talk to Chuck again about the nature of his inability, but explain to us, if you will, what we all regard as just automatic and natural, the ability to recognize a face once we've seen it. How does that operate, and what's that about? And is the face peculiar as opposed to, a leg or a chest?
Well, I just want to step back a little bit and say, referring to the brain, studies, the kind of work that Marge and her colleagues show that in the monkey brain, half the brain is devoted to vision, and in the human brain, it's very largely the case. So I'm a visual psychologist, and if you think of half the brain devoted to vision, that's vision stacked up with everything else, thinking, all the stuff that you learn in school. There's vision. So first of all, I think that we don't really know that much about vision, but we do know a few things, and one of the things we know is that it probably is many, many things. There are many studies that recently can show that people basically are blind, but they can actually pick up cups. So there's a whole part of vision that has to do with motor coordination. There's a person in Germany that can see just fine, but she can't see motion. And one of the things that, not surprisingly, visual system is very, very good at and very specialized to, and Marge will talk about it to some extent, is that there's special machinery in our brain to do with faces. If you think about your whole life, particularly in our social situations, we're looking at faces all the time. We're getting information about the faces. It's not just recognized, basically saying whether the person believes me, whether they think I'm a cool guy, or whether they, whether they're happy or sad. So we have a tremendous amount of intelligence in our face recognition. So, and then of course, about 50 years ago, people started noticing through war wounds and things like that. There were some people, after they had brain injury, basically couldn't recognize faces at all. They woke up after the war wound, they just couldn't see faces. Very, very obvious. And that was dubbed prosopagnosia. Now, very recently, so that's very related to the kind of work that I think Marge will tell us more about, and that there's special portions of the brain which are devoted to face processing. I'll let her talk about that. But it so happens, and this just happened about 10 years ago, there's reports of just ordinary people some ordinary people have very great difficulty recognizing faces, to the extent that the kind of thing Chuck is alluding to, that they just really couldn't many people have very, very difficult time, and they don't even know it. Chuck knew that early in his life, but I've been on radio and TV a lot, and people write me letters and say, now I understand my life. I'm 75 years old. And so we've done surveys, we've interviewed thousands of people, and our guess, and it's not just our guess, is maybe 2% of the population has really severe problems recognizing faces. And so that's just one form of visual intelligence that's very important, and we don't really know what it is, but probably it has something to do with specialized parts of the brain not developing, and I think that's part of it, but we don't really know all the answers. We're just delving into it right now. So we think that to answer your question more directly, it probably are some specialized parts of the brain. These people are fine at many other things. Some people have comorbid symptoms, they get lost and things like that, but there is a population of just have problems with faces, and that may be related to the specialized nature. As I said, we have multiple sort of visual intelligences, and face processing may be one of them. I just mentioned one thing about the 2D and 3D part. I never thought about this until this came up on the panel, but we study these prosopagnosic individuals, and many of them can recognize photographs. I mean, they're not great at it, but then they say, real life is much, much harder, because I can memorize a photograph, but real life is really much worse. So maybe that says it.
I can watch a movie and I have no idea who the actors are. I mean, I see the actor on the street, I won't know who they are. And they're the most recognizable faces on Earth. In my current show, shameless plug, at Pace Wildenstein on 26th Street through the 20th. Be there, there'll be a quiz later. I did something really unusual for me, which is, from the very beginning, I painted ordinary people. Some of them got famous on me and screwed that up, but I wanted ordinary people, not superstars that Warhol was doing, or famous people. In this show, I have a painting that I did of Bill Clinton. One of the most, probably up until our current president, probably one of the most, if not the most recognizable man on the face of the earth. And it was an opportunity for me to see how different it was to make a painting the same way I make all the paintings, with somebody who is instantly recognizable as to everyone. As the other people are ordinary. And I think it's an interesting, I did it for my own sense of what this would be like to do a famous person once. But I think it might offer the viewer an opportunity to see if they look at that painting differently because they know who it is, rather than unless they know a lot of people in the art world, they won't know who the other people are.
Well, it connects to what we were talking before about Devorah's work with the best known Da Vinci in the world and a lesser known Da Vinci, and the recognizability there. Ken, I think you have some images, don't you, including Bill Clinton's wife as one of your images to show the recognizability or unrecognizability. Do we not have some?
I think we just could. Well, this is so some of the prosopagnosics report that even looking at themselves in the mirror, they don't recognize them. I've been corresponding with Oliver Sacks, and he's reported to have said this. But many very famous people can have very bad problem with face recognition. Let's go to the next one here.
It's a sliding scale, though. I mean,
yeah, definitely. This is an early version of. It's not Chuck Close, but it's an early version of parts and wholes. Many of you have seen Archimbaldo paintings, and there is an actually individual who has perfect face recognition, can't recognize anything else. He only sees the faces, he doesn't see the vegetables. And then they're the opposite. This next slide. And this is the Clinton one. The Thatcher and Clinton in their younger years, and some of you have done Mad Libs and things like that. And it's very hard to recognize the top of Thatcher, the top of Clinton. When you combine them, you reverse them, they're new people. And that's the idea of the faces that we've studied over and over again, that it's the parts, but it's also the whole. Somehow when we recognize faces, not just by the end. Parts are important, but the whole is important. That's what makes faces very unusual. They're very our object recognition system for faces is so much more sophisticated than any other object that we just process it in so many different ways. I'm not sure what else is coming up here. This is I'm very interested in attractiveness as well, in the sense that what are the features of attractiveness, facial attractiveness, and some of you read this in popular press and things like that, but if you just take the two faces on the left, they're okay, but then if you just average them, it's a really beautiful woman. And then if you there's a male and a female, male on the right, female on the left, the average male and the average female looks generally quite a bit more attractive than your average, than a particular person. And another aspect of attractiveness, and the next slide there, is in female faces, it's sort of degree of femininity. You can just take on the computer, you can just sort of jack up the masculinity, and people usually rate a more exaggerated feminine face more than a masculine face. What's interesting is that the prosopagnosia, and we've studied hundreds of them, have very difficult time in recognizing who the person is, but they have not much difficulty in seeing whether a person's attractive, whether they're more masculine or feminine. So it's more with respect to identity.
I have a William Wegman photograph from 1970 in which he took identical twins and superimposed the two images, and the fake triplet, which is the combination of the two, is much more attractive than either of the...
So go back to this one, go to the previous slide here. So do you notice a difference in that, Chuck? Sure. So he's prosopagnosia, but he really can see the difference in those two faces. So it's not, he's not really face blind. He's just blind to people's identities, which is very interesting. The next slide here. So a lot of cosmetics is really to make faces exaggerate the femininity of the femaleness of the face. And that's something that cosmetics experts for thousands of years have understood. I don't know if that's the last one or not. Let's see, anything else? Oh, this shows you that right side up face. If you do Mad Libs with the left and the right, this shows that there's something called the inversion effect, which is very important. We're used to seeing faces when they're right side up. And just to give an idea of what prosopagnosia is like, so Thatcher looks really much worse on the right than on the left, because we are much more sensitive to right side up faces. I think the next slide is going to be upside down faces. Lots of celebrities, they're upside down. Then you can recognize quite a few of them, just search around there. But if you turn the faces right side up, then you can see the celebrities much more. So if you want, just to give a sort of vague idea what prosopagnosia might be like, it's as if you were looking at people who are upside down. So try that for a while, and you'll sort of get an idea what some people are. And also say that for many of you in the audience, if you're interested in the subject, and I would say to the audience of 500 people, maybe there are 20 people in this audience that might have prosopagnosic symptoms. You can come to our website and check in and be tested and things like that. So this website called faceblind.org, and we have ways of doing research on you. We'd love you to show up.
We have ways of doing research.
We just basically they're all very benign and harmless.
Thank you. Ken kept saying, Marge, that you were going to explain how this works on the inside of the brain. So now it's up to you to tell us how this works. How, for instance, in caricatures, which we all are, which are in a certain way distillations.
If you put the visuals on, I'll narrate as it goes along. Supposedly we have 43 seconds. Can we have something visual that's going to happen, I hope? So we're very good at recognizing faces. These images are coming at you at 10 per second, and not only do you tell when I put a face in that series, you know who it is, right? At least some of them. We can recognize faces when they're degraded, when they're distorted, when they're disguised, and we're better at it than any computer program. Primates in general are very good at recognizing faces. And artists have stop. Slow down, go back. Go back to just the two on the left. Okay, I didn't finish my spiel. So artists have toyed with what are the underlying mechanisms of face recognition, and one of the things that artists figured out long before us neurobiologists is that a caricature of a face, and Ken was talking about the feminization of a face, the way that's in a sense a caricature of femininity, is what you do is you take an average face or an average male face and an average female face, and you subtract them and you say what's the difference, and then you add the difference to the female face, and that feminizes it. So if you take an individual and you subtract that face from the average face, that difference, if you add it to the individual, is a caricature. So here are two veridical line drawings of two individuals, and there are two caricatures of the same individuals, and I bet you found the caricatures easier to recognize than the veridical individuals whose photographs are in the next panel. So a caricature is easier to recognize. That tells us something about how we recognize faces. So I forget what the next slide is. We studied this. Yes, we recorded from face cells, and we showed them a stimulus like this, a series of faces that varied in all kinds of flat dimensions. And we asked, what do face cells care about? So do you have one cell that responds only to a particular face, or do you have a cell that responds to big mouth, small eyes, pear-shaped face, and so on? And so we just asked this question, and we found, so you might imagine that you would have cells that coded, so first of all, we found that there were cells, all of the cells in our population, responded to different variables. So you'd have some cells that cared about how far apart the eyes were, you'd have some cells that care about how big the eyes were, some cells that cared about how far apart the mouth and the nose were, and the cells tended to be coding constellation of features, which is probably how we get the fact that we code faces holistically. But you might imagine that you could have cells that coded inner eye distance, which is what I'm showing here, and that you'd have a bunch of different cells for every possible inter eye distance, going from Jackie Kennedy to Bill Clinton, with one cell for every possible distance in between. But that's not what we found. Instead, what we found was that the cells tended to be strongly excited either by one extreme value or another extreme value. So you'd have one cell likes really big inter-eye distance and another cell likes small. So that means that, first of all, that's much more efficient. You see, you only need 2 cells instead of a half dozen of them. But it also means that the way we code faces is like caricatures. You tell how different somebody is along what dimensions from the average face. It means that you have the big eye difference, or the big eye cells pitted against the small eye cells. That is, you code faces by a push-pull or a reciprocal mechanism for big or small, large distance, small distance, and so on. And that explains one of the most interesting phenomena in face recognition, I think, which is the face after effect. So what I want to do is go to this next image. Oh, sorry. Great artists recognize this, right? So these are a bunch of drawings and paintings by Picasso, but what I've done is put them next to a photograph of the individual of whom it is a painting. And you'll see that they're all caricatures. So they're various wives, Picasso himself, girlfriend, mother-in-law, so on. But they're all caricatures. He's picked out what's unique about each of those individuals and exaggerated it. Now, I think the next one goes on to the face after effect. I hope so. Yes, so what I want you to do with this image is see those numbers in the middle? I want you to, so I'm going to blab on a little bit. What I'm trying to do is to get you to spend about 30 seconds looking at those numbers, adapting one side of your visual system, one side of your visual field to Angelina Jolie, and the other side to, what's his name? Brad Pitt, sorry. And if you'll do, and the reason that I'm having you look up and down is because I don't want this to be a pure retinal adaptation. I want this to be an adaptation to the overall gestalt of each of these faces. Okay, so now I think I've blathered around long enough, and what I want to do is go on to the next image, and you look at the center. Can we go on to the next image? No? Yes, perfect. Now, did you get a face after effect? These are 2 identical images, which you're now gradually beginning to see. And so you had an after effect that made you see Angelina Jolie on the right and Brad Pitt on the left. because you adapted to all of the different dimensions along which these two individuals differ. So now I'm done. It's over.
And on the frightening image of Brad Pitt and Angelina Jolie merged, I want to thank Margaret Livingstone, Ken Nakayama, Chuck Close, Devorah Sperber, and Christopher Tyler. Thank you all very much. Thank you.